Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about LED configuration. First of all, for optical fiber communications, the three things are very important. One is the optical fiber, second one is optical sources, next one is photo detector. Now coming to the optical sources, so we have two important sources we have. One is LED, next one is laser. The LED is nothing but the light emitting diode, and coming to the laser is nothing but the light amplification by stimulated emission and radiation. So as I said earlier, LED and lasers are the two sources. So LED is suitable for a short distance and a low bit rate application. Mainly for short distance communications, we can go with the LED. For laser, so here you can prefer the long distance communication. Okay, also the laser which have high bit rate. Now coming to the LED structures. In the LED structures, we have the surface emitting LED and the edge emitting LED. The LED is a light emitting diode. Here, what will happen, the main thing is the electron holes per recombinations, so will produce the photon energy in the form of light. That's why we call it as specialized LED. The emission of radiation the form of light. Generally the normal diode, so just the electron holes per recombinations will occur, but here also same, but it can emit some radiation in the form of light. You can call the emission of energy is nothing but the photon energy. Now in the active region, so here only the radiation is present, there is nothing but the light source is present. Okay, so let us come to the configurations. Here in these configurations, so we have some layers. The first one is heat sink. So the heat sink is the one, so here it can emits the heat out, because without heat sink what will happen, so it may damage the circuit, so that's why we can use the heat sink to emit the heat out. Next one, metallization, which gives support to the structure. Another one thing is SiO2 isolation. So these isolations will form a isolation layer with the active region. Okay, so then it provides some disconnect or discontact between the confinement layers as well as the active region. So we can use the SiO2 isolations. Another very important thing in the layer is nothing but the confinement layer. Okay, so which is supporting to the active region. We can call it as a double heterojunction layer. You can call this layer nothing but the double heterojunctions layer. So here in between, so we have the active sources. Above that we have the substrate material. So this is the basic structure of the surface emitting LED. Now we have to make the circular HUL. Okay, so where the fiber can be placed in the 90-degree perpendicularly. Also here we can use some bonding material. So here which can be, fiber may not be moved further direction, thus we can place some bonding material. So here which can be easily catch with the active region. Now if you see, so here from the active region, as we know earlier, the active region is nothing but just the electron source per recombinations. So here the electrons, the energy may be emitted out in the form of light. Okay, so here we are placing the fiber perpendicularly. So my LED source may be emitted perpendicularly at the surface. So we can call it a surface emitting LED. Fine. Now coming to the surface emitting LED, so another important point. So that is the structure. Okay, so not only that, so here we are having some dimensions. So what is the maximum dimension? The circular active area of the surface emitter is nominally 50 mm in diameter and up to 2.5 mm thick. Also another important parameter is the emission pattern. It's a isotropic with a 120-degree off hour beam width. These two are a very major important thing. Now the well is properly etched through the substrate of the device, in which the fiber is properly cemented and it can be accept the emitted light. This is the concept behind the surface emitting LED. Okay, so now this, as we know that this emission pattern is essentially isotropic with a 120-degree off hour beam width. So this pattern from such a surface emitter called the Lambert-Eaton pattern. So what is special of this one? In this pattern, a source is equally bright when you viewed from any direction. So this is the main advantage of this pattern, is here the source is equally bright when we view from any direction. So this is all about surface emitting LED. Now coming to the edge emitting LED. Here the structure is almost the same. The whatever the surface emitting LED, the same as the edge emitting LED. The only one thing here, the heat sink is there, the metallization. So for electric contact, then substrate material, so the confinement layer, but everything is there. Here we can place the active region in the edge. So this is a major difference between the surface emitting LED and the edge emitting LED. Now coming to the structure, the same heat sink. Now if you see, the emitted wave can be, so the light can be emitted, so in this incoherent optical output beam. Okay, so in this, so we can view the angle. This is very important in the edge emitting LED. Okay, fine. Now coming to the dimensions here. Here these guiding layers have both a refractive index lower than that of the active region, but higher than indexing of the surrounding material. So we know the importance of refractive index of the fiber. So this guiding layer have the refractive index should be lower than of active region, but higher than the surrounding material. That is very important. Okay. Next, this structure forms a waveguide channel. It's like a waveguide channel. So that directs the optical radiation towards the fiber core. Another important one is, so to match the fiber core diameter, the contact strips for edge emitter are 50 to 70 mm wide. Normally, the length of the active region is usually ranges from 100 to 150 millimeter. So this is a one. So these are the major construction details about the edge emitting LED. Thank you.